Hello and welcome. My name is Matthew Whited, and this is my entry for the Dare to Dream Different challenge using the .NET Micro Framework. The number one problem I have seen with consumer goods is a lack of centralized time sources. On networks, we have time servers to help keep ourselves in sync. I don't know about you, but I hate all the different time zones I have around my home. Even with clocks in the same room, it's pretty unlikely they'll all be set at the same time. I decided to solve this problem by starting with the most important clock in my home, the alarm clock. In this demonstration, you will see how NTP, or Network Time Protocol, as well as other internet resources, may be useful at organizing your life. Let's take a look, shall we? First, let us examine the hardware used for this device. The base device for this project is the Tahoe 2 Micro Framework Development Kit from Device Solutions. The interfaces that I will be using on this board are the Serial Peripheral Interface, otherwise known as SPI, the Inter-Integrated Circuit, or I2C, Ethernet, and various general I/O ports. The AR1010 from AirHoya Technologies is an I2C controlled FM radio receiver. Also on the I2C bus, I have a DS1307 real-time clock with battery backup from Dallas Semiconductor. On the SPI bus, I have the VS1011E MPEG audio codec from VLSI Solutions for decoding MP3 audio. All of the drivers for these devices were written in C# and are fully managed and object-oriented. Let's see them in action, shall we? Let's reboot the device. On boot, the device comes up to display a simple analog vector graphic clock. This can later be augmented in various forms, such as a digital 12 or 24-hour clock, or something more graphical. Next is a weather report. This is powered off of the Yahoo Weather, and you can see we'll display the current condition icon as well as the wind, the temperature, and direction, speed, and so on. It also gives you the forecast for the next 2 days. The third display is the FM radio interface. This displays the current station, the signal strength, and the volume level of the device. And you can see I can also turn it up, and you'll hear the music in the background. You can also mute and change channels. This next display is a contact list powered by a simple WCF service that's reading the contacts out of my Outlook email on my computer. It's a simple XML based RESTful service that you can put on your network and share the data out. This caches up to 5 at a time, and then you'll see a little lag as it downloads the next page of 5, and it'll go on through. The next display is the appointments out of my Outlook email. This screen, you can see, will download all the appointments for the current day. In the future time, this could have a full calendar on it, and it would allow you to set things such as alarms and so on that would actually be controlled on this device. To see how the state can be controlled from any screen, I've added the functionality to several of the screens to still be able to control the FM radio's audio level for volume, muting, and so on. Future plans for this device will allow for customized schedules and event-driven alarms. Some of these events may be things such as severe weather reports, congested traffic, or disastrous and unfortunate news. This would help people stay better prepared and more organized for their life. Other future interfaces may be to allow for control of home automation and full multimedia support. So you can do things such as wake up to your favorite podcast or news report from the other side of the world. Overall, I am very impressed by this platform. It is by far the simplest development I've ever done with embedded systems. Normally there's a ton of mucking around in the underbellies of opcodes, system registers, and manual memory management. The improvements to the design process by using .NET on embedded systems is astonishing. Simply declaring a new thread and tell it to start is very wonderful. Things I would like to see. Being that it's an embedded system, I would like to have some lower level interfaces as well. A way to call memory mapped devices from C# instead of relying on the porting kit to gain access to these in an unmanaged fashion. Another handy feature would be turning this platform into a more real-time system and still keeping the power and flexibility of .NET. I hope you enjoyed my presentation. Thank you.